Good day everyone. In today's video we're going to talk about first order differential equation. What does it mean when an equation contains dy ds? For example, we're having dy ds is equal to 3x. How can we find y? How can we find y itself? We have to integrate, right? So we're going to multiply both sides with ds. So we're going to have dy is equal to 3x dx. So when we have dy is equal to 3x dx, we're going to integrate both sides. If we integrate dy, we're going to get y. If we integrate 3x ds using the power rule, we're going to get 3x squared over 2 plus some constant c. So this is our y. Alright, so the next equation we'll be considering will be in the form dy dx plus p of x y is equal to q of x. So this is called the standard form of a first order differential equation. And if an equation is in this form and you are asked to find your dy ds, there are some terminologies you must familiarize yourself with. Some of them is called the integrated factor. The integrated factor has a general formula of exponential integral of p of x dx. Exponential integral of p of x dx. You must memorize this equation. So this is the general formula of integrated factor. Alright, so if you want to get y from this this form of equation, there are two ways to do it. We have the general method, and of course we have the formula. The formula to get y is this: y is equal to 1 over the integrated factor multiplied by integral of integrated factor multiplied by q of x. Q of x, this one here, q of x dx with respect to s plus c. You must also multiply it by c. This will be the general formula. You must write this down on your note and memorize it. Okay. Alright, so we're going to be solving some of the examples we have. For practice purposes, we're going to be solving some of the examples. And in the next video, which will be around anywhere around this video, just click on it. That will be about the application, how you can apply it in terms of engineering perspective. Alright, so let's solve some examples. Alright, so let's say we have dy dx plus 2y is equal to x. How can we find our y in this case? Alright, this is in the form of dy dx plus p of xy is equal to q of x. Now comparing the equation, we can note that p of x is 2, because this is y, this is y, so p of x is 2. So it means that our integrated factor is equal to exponential integral of what? P of x dx. You must memorize this equation, which is equal to exponential integral of p of x here is 2 ds. And if you integrate 2, you are going to get exponential 2x. So exponential 2x is our integrated factor. We are going to be using the general method first of all before we use the formula method. So the first method you must write down is that you must look for your integrated factor. That is the first step in the general method. You must look for your integrated factor, after which you multiply each term of the equation by the integrated factor. So we are getting our integrated factor to be exponential 2s. So the next thing to do now is to multiply each term of this equation by the integrated factor. So we're going to have let's do it here. dy dx dot exponential 2x plus 2y dot exponential 2x is equal to x multiplied by exponential 2x, right? So this is the first step. After you must multiply each term by the integrated factor. So the next thing is to factorize y out. There's y here, there's y here. Then you take 1 exponential 2x, forgetting the coefficient of 2. This works because even though we do that like y dot exponential 2x, like we say we factorize like this, and we now say is equal to x dot exponential 2x. If we differentiate this dx, if we differentiate this using the product rule, because these are two functions multiplying, we are going to end up having this back. That is why it works. That is why it works. You can pause the video and differentiate this using the product rule. You are going to get this back because you're going to differentiate this implicitly. If you don't understand implicit differentiation, check my videos. I have a video on that. So what should we do next? The next thing to do now is to integrate both sides. Now when we integrate both sides, this will cancel out. So we have y exponential 2x is equal to integral of x multiplied by exponential 2x. Here we are going to use what we call integration by parts. Why are we using integration by parts? When we are having two functions multiply inside an integral symbol, the best way to do it is integration by parts. Alright, and what's the integration by parts saying? Integration by parts is saying that when we have u dot dv multiplying is going to give us uv minus integral of v du. Right? So using the formula light, we can determine what our u value will be first. So arithmetic, so our u will be this. So we can say that our u is x, our du is equal to dx, our dv is exponential 2x, our v is integral of exponential 2x, which is equal to 1 over 2 dot exponential 2x. So it means that our x dot exponential 2x is equal to uv right, minus integral of v, take our 1 over 2 out, multiply it by du, which will have what, ds now. So you can see that it works. So we're going to have this to be equal to x exponential 2x over 2 minus 1 over 2 dot. When we integrate this, we're still going to get 1 over 2 exponential 2x. Then we add our constant of integration. So everything here is equal to this. So if we divide both sides with exponential 2x here, we're going to get y. So it means that our y is x exponential 2x, right, all over 2 minus 1 all over 4 exponential 2x plus c, everything multiplied by 1 all over exponential 2x, right? Yes. So exponential 2x will affect each term, including the c. So it means our y, let's write it up here. There's no more space. It means our y is equal to is equal to x over 2 minus 1 all over 4 plus c exponential negative 2x. So this is our y. I believe you understand. Alright, so let's try another one. The next thing to do now, let's verify it using the formula y is equal to 1 all over the integrated factor multiplied by the integral of the integrated factor dot q of x dx plus c. So we have our integrated factor to be exponential 2x as calculated initially. Integral of what? Exponential 2x. Our q of x from the equation was just x, right? Then we have plus c. You just have to integrate. The long cut we did there, this is just the short form of everything. We have to now integrate this using the differentiations by parts, and integration by parts. So when we did that, we got, so y is equal to 1 all over exponential 2x. When we did the integration, we got x exponential 2x over 2 minus 1 all over 4 exponential 2x, then plus our c here. No, we'll still end up having the same answer. So the general method, the formula is just the summary of the long method. So it's advisable if you memorize this formula. Now let's try another problem. Alright, so what if we have dy dx plus 1 all over xy is equal to let's say is equal to sine x. Go ahead and pause the video and give it a try. Alright, so I'm not going to use the general method here. I'm going to use the formula. It's already in the form of dy dx plus p of xy is equal to q of x. It means that our p of s here is 1 over x, our q of s here is sine x. So our integrated factor is equal to exponential integral of p of x dx. So this is equal to exponential integral of 1 over x dx. So this will give us exponential ln x, and ln has the base e, so it will cancel out with this. So our final answer is just x. So we're going to use the y is equal to 1 all over the integrated factor multiplied by integral of integrated factor multiplied by q of x dx plus c. And we know that our integrated factor, let's continue here. So our y now is equal to 1 over our integrated factor. We calculated it as x into brackets integral of integrated factor is dx dot our q of x now in this, our q of x in this case is sine s. So we're going to put sine s here plus c. So we're just going to use our integration by parts again to compute this integral. Then we find our y. I believe you find this video very helpful. If you did, please subscribe to the channel and stay tuned for the next. And again, you can be part of our community of active learners. Link will be in the description, so you get notified immediately there's a new video dropped here. Thank you and see you in the next.